Hello everyone, today we're going to be graphing quadratics from Vertex Form. We have two main goals. The first one is to actually graph the quadratics in Vertex Form. The second main goal is to, after we've graphed it, then analyze the functions. So the first thing is we need to know what a quadratic function is. Quadratic functions can be written in two different forms as of right now. Standard form is y equals ax squared plus bx plus c. Or vertex form, which is y equals a parentheses x minus h squared plus k. In both of these, a cannot equal 0 because then it would not be a quadratic function but a linear function instead. If we were to graph a quadratic, the basic graph of a quadratic is called a parabola. It looks like a U and it can be stretched or reflected up and down or left and right. The vertex is going to be where our parabola goes from decreasing to increasing or vice versa. It is either going to be the highest or the lowest point on the graph. For the graph that's here, we can see our vertex is down at -2, -9, and you see it written as a point. In standard form, if your a value is greater than 0, your a value is again the number out in front of your x squared term. So if that number is greater than 0, meaning if it is positive, then your graph is going to open up. And if your graph opens up, that means your vertex is going to be a lowest point, which is also known as a minimum. If it's the opposite, where a is less than 0, meaning a is negative, that means your graph is going to open down and your vertex is going to be your highest point, known as your maximum. The axis of symmetry is something that every parabola has. It's going to be a vertical line through your vertex. We a lot of times see it as a dashed line. And it's going to act as a mirror. And the graph should be symmetrical about it. That's why it's called the axis of symmetry. So whatever you see on one half of your graph should be identically matched on the other side across the axis of symmetry. We're always going to write the axis of symmetry as a vertical line. So you should always see it written as x equals some number. So as you can see on the graph over here, it's x equals -2. Your x-intercepts are going to be where your parabola crosses the x-axis. And your y-intercept is going to be where your graph crosses the y-axis. Now we know a little bit about the shape of quadratic functions. Let's go ahead and look at the parent function of quadratics and look at how vertex form changes things. For the first thing we're going to do is look at the graphing from vertex form. So on the right-hand side of the screen, you can see that our vertex form is a parentheses x minus h squared plus k. The x-coordinate of your vertex is going to be h. You'll notice that you take the opposite of whatever sign is on the inside of the parentheses. The y-coordinate is k. So therefore your vertex would be h comma k, where h does the opposite of what's inside of the parentheses and k just keeps whatever sign is with it. After you find your vertex, quadratics are all going to use the pattern 1, 3, and 5 multiplied by whatever your a value or your stretch is. Once you find those values, you can go over and up that amount from your vertex to find the rest of your parabola shape. The axis of symmetry is going to always go through your vertex, so whatever h is, your equation is going to be x equals that number. And for your x and your y-intercepts, you look at your graph and you write those as points. So let's look at specifically the parent function. You'll notice with this example 1 that a is 1. There's technically a 1 out in front. H and k are both 0, meaning we're not shifting left and right or up and down at all. So therefore our vertex is going to be 0, 0. Then what we're going to do is we're going to take that 1, 3, and 5 pattern and we're going to multiply by your a value, which is 1, which means from my vertex, I'm going to go right 1 and up 1. I'm also going to go left 1 and up 1. From there, from that specific point, now I'm going to go up 1 and up 3. That's the next one, the 1, then the 3. And I'm going to go over on the other side and match it, go over 1, up 3. And then the last one is over 1 and up 5 on both sides from your new point. That's going to give you that nice parabola shape or that nice U shape. So again, that pattern is 1, 3, and 5. Once we start moving it and stretching it and everything, we'll show you how A changes those numbers. Now we can look at the graph and notice that the axis of symmetry here would be the vertical line through your vertex. It's going to always be x equals a number, and it's always going to match the x value of your vertex, your h value. So this one's going to be x equals 0. My x-intercept, my graph crosses my x-axis at the origin, 0, 0. The arrows on my graph are pointing up, and that's because my a value was 1, which is a positive number. Since my a value is 1 and my graph opened up, that means my vertex is a minimum value, and the minimum value happens at 0, 0. All quadratic functions have a domain of negative infinity to positive infinity, and that's because on your graph you're going to the left for forever and to the right for forever. You can see that with the arrows on the left and the right parts of your graph. Your range is going to be from low to high. So the lowest this graph gets here is at 0. It actually touches 0, so we're going to use the brackets, and then this graph has arrows pointing up for forever, meaning it's going towards positive infinity for forever. Your range is going to be different for each graph that you do. Let's take a look at another one here. So you notice this one has A, H, and K. So my A value is 2. That means this is a vertical stretch of 2. My H value is going to be the opposite of this. So my H value is -3, which means I'm actually going to be moving my graph left 3. And my K value here is going to be the +1, and that moves my graph up 1. So if you imagine taking your point and moving it left 3 and up 1, you can imagine that point there. That's going to be your vertex. It's at -3, +1. Again, notice whatever's inside the parentheses flips, and it becomes, instead of a positive, it becomes a negative. And then for your K value, whatever your K was, this was +1, it remains the same. This graph is going to open up, and I know that because my A value is 2, which is a positive number. So that means my graph is going to look like this. My axis of symmetry is going to be x equals, and it's always going to be the x value of my vertex. So that's the h value. I don't know my x-intercept or my y-intercept prior to graphing, but my domain here is going to end up being negative to positive infinity because all quadratics, I can plug any number in for x, so there's no restrictions on my domain. And we can wait to do our range as well. So now we have to do the other part. Let's go ahead and do that 1, 3, and 5 pattern. So that's our graphing pattern, the 1, 3, and 5. What we're going to do is we are going to multiply that by our A value. Now our A value for this one was 2, and that's what stretched everything vertically by 2. So my new numbers here are 2, 6, and 10. Now what that means is from my vertex, I'm still going to go over 1, but instead of going up 1 initially, I'm going to go over 1 and up 2 initially. I've done the 2 part. From these new points, I'm going to go over 1 and up 6. I'm going to do this on each side from my new points, over 1, up 6, and then I would go over 1 and up 10 from there, but I'm off of my graph grid. From here, I'm going to create my parabola, again trying to make it look like a U shape and not necessarily a V shape. Some of them that get stretched kind of look like V's, but again, these are supposed to look like the U, the quadratic, the parabola. Now based off of my graph, I can see that my x-intercept, I'm not going to have any because this graph doesn't cross the x-axis. My y-intercept, I don't exactly know what that is. It's going to be 0, something, but I don't know what it is. I can't tell based off of my graph, so I have to go about this a different way. I'm going to take my equation at the beginning, and I'm going to say when x is 0, what is y? Because that's really what your y-intercept is asking. When x is 0, what is y? So we are going to get 0 plus 3 squared, and then we're going to do order of operations. So we're going to do 3 squared, which is 9. 2 times 9 is 18. So my y value here should be 0, comma 19. And it kind of makes sense with me going over 1 and up 10. I would have been there anyways. And then for this last graph here, my range here, low to high, my range starts at 1. That's the lowest my graph would go, and it actually touches it, so I use a bracket. I'm going up for forever, which means it's going to go to positive infinity for my y values. For our last problem here, we're going to write the equation of a quadratic function given our vertex and our vertical stretch and reflection. So what we're going to do is we're going to kind of set up the frame here. It's going to be y equals a, and then x minus h squared, and then plus k. So this 4 here, this is going to be my h value, so I'm going to put a 4 here, but normally when I get my h value, I have to remember that I flip it. So this is actually going to end up being x minus 4. My k value here is minus 3, and so this one here, instead of actually being a plus sign here, my k value is going to be a minus 3 because I keep whatever sign is with my k. I see my vertical stretch, which means my a value is 3, but then I also see that it's reflected over the x-axis, which means it's a negative 3 out in front. So the equation for this one that works is y equals negative 3 parentheses x minus 4 close parentheses squared minus 3. Thank you very much for listening, and there are 2 practice problems that you can complete after this just to make sure that the graphing of quadratics in vertex form went okay.